So this is a assignment problem. Is this kind of it's a kind of transportation model. It's more kind of more specific. It's like a subset of the transportation model. And here the what happens is that the supplies and the demands are all just equal to 1. And this kind of thing is convenient for like matching up things, matching up people to jobs, matching up matching up like the jobs to do to the schedule time in the day, or even matching up like classes to the time slots. So it's kind of convenient for matching, and you want to match in the kind of the best way. So either you want to minimize something or you want to maximize something. Okay. What we have here is this is again another example from your book. It's in section 10.2. Here what we have is we have 3 jobs to do and then 3 people to do them. And we want to match the 3 people to 3 jobs so that each person gets at most 1 job and each job gets assigned someone. So the number of people assigned to each job should be equal to 1, and number of jobs assigned to each person should be equal to 1, or it could be less than or equal to 1. Okay, so here, what kind of jobs are there? We got this market research projects. There are 3 of them. You got 1, 2, 3. And then we have the 3 people to lead these projects, Terry, Carr, and McClemens. So we got the 3 people here. Okay, so we want to assign these 3 people to these 3 jobs. We want to, the goal is to minimize the sum of the project completion times. So that is, if I sum up the time it takes to do project 1 plus project 2 plus project 3, that sum should be the minimum possible. Okay. And it says that each project leader can be assigned to at most 1 project, and each project must have exactly 1 leader. So we could think of this again as a kind of a transportation problem. It's kind of like the leaders are the origins, and the projects are the destinations. And the projects are demanding 1 leader, 1 person, so demand is 1. And each leader can be assigned to at most 1 project, so the supply is 1. The number of projects the person can be assigned is 1. Okay, and so you could think of it as also as a network model. So here we got the people, and we have the projects, and we have Terry, Carl, McClemens, and we have projects 1, 2, 3. Okay. And we have the supply is there 1, 1, 1, and demands are 1, 1, 1, and we have this. It's like you have like shipping routes here. Okay, and each route has a cost associated with it. So what are these? What are the costs? Here it's the number of days. It's not. These are estimated. So I don't know how they got these numbers, but maybe they asked these guys. Okay, here's a description of the project. What is your estimate of the time it'll take you to finish the project? So maybe Terry said maybe 10 days estimate to finish 1. But if it was assigned to project 2, it would take him 15 days. If it's 3, it would take him 9 days, and so forth. So these are the time estimates for each pairing, how long it will take if you assign that person to that project. Okay, so here. So we could think of these as like a shipping cost. So it's like Terry is 10:15:9, and Carl is 9:18:5, and it's 6:14:3 for McClemens. So you could think of it as like you're like sending these people to these projects, But you got 1 for supply and 1 for demand for each. So first we could think of this as, okay, well, the door is closed, but it's still a little. Can you guys move away a little bit? Thank you. Okay, so let's see. We are, where are we? Okay. So what we could do is we could again do kind of minimum cost method, and we could kind of get a feel for what's going on. So what we could do is we look at these numbers and pick the lowest number, each step. So I could say, so we choose lowest value at each step, and that will be again a heuristic. It would not guarantee an optimal solution. Okay, so out of these we pick the smallest number, and what is that? Okay, the smallest number is 3. Okay, 3. It's okay. Maybe the question was too easy. Yeah, so it's a 3. Okay, so it's like in a first grade class. Okay, here are some numbers. What's the smallest number here? So we have 3, and now we have okay. Once we pick this number, now we got to update. Okay, we got to update. So we got to cross out things. Okay, so 3. Project leader, no, project is assigned as McClemens guy. So McClemens is gone, and the project 3 is gone. Okay, now out of these 4 values, we pick the smallest number. So that's a 9. Okay, now the project 1 is taken care of, and Carl is now no longer available. And this is pretty short problem. So here 15 is the only thing left, and that's it. So Terry gets to go with the project 2. Okay, so it's Terry goes to 2 and so forth, and maybe I'll change the color here. Terry gets 15, so we're kind of, here's the assignment we're making. 15. And then Carl goes with a 1, so that's a 9. Like this. And McClemens is assigned to project 3, so that's the 3 is the time, and here is the assignment. So again, this is a pretty good assignment. It should be close to the best possible, but again, there is no guarantee. So if we were to use this assignment, then total time, the sum of the project completion time will be just the sum of these 3 values. So it will be 15 plus 9 plus 3 as 27. Right? So 27 days will be the total time to complete the 3 projects just by adding them together. So that's a heuristic. Okay, so that's a heuristic. And now let's talk about how to do this in a kind of linear programming model. Again, to have a linear programming model, we need to start with the decision variables, and we're going to have again x 1 1 1 2 1 3 2 1 2 2 2 3 and so forth. So this is going to be 1 1 1 2 1 3, and okay, make this a little thinner. And then you have 2 1 2 2 2 3 and 3 1 3 2 and 3 3. Okay, so an x could be only 1 or 0. So 1 means there was an assignment, 0 means there was no assignment. Here what we would say is, if I were to look at this this solution, we would say, well, x21 is equal to 1 because I matched up number 2 and the person 2 to project 1. So 21 is equal to 1, and here what would we say? X what? And what does this represent? That's 1 2, right? So 1 2. Row number is 1, column number is 2. So that's a 1, and this is 3 3, right? So x3 3 is equal to 1. So in general, the definition is something like this: xij is equal to 1 if the person I is assigned to project J. So the person number is the first one, the project number is the second one. The person number is the row number, and the project number is the column number. Okay. So like here we would say in this assignment, here are the ones, and all the others are zeros. So we would say x, for instance, x11 is, well, there's no assignment here. So Terry is not going to work on project 1 in this case. So x11 is equal to 0, and x31 is also equal to 0. And then here it's a 1 2 is 1, and x22 is 0, x32 is 0, and here x x13 is 0, and x23 is 0. Okay, so you could kind of see that in each column there's only one 1. Right? In each column there's only one 1 because each project should get only one leader, and in each row there will be only one 1. So only one place that has 1, because each person only gets one project. So that's why here we have something like this. The row total is less than or equal to 1, and the column total is equal to 1. So no more than 1 is allowed. And here's kind of the model of what it'll look like. Okay, the times that are given are now your coefficients. These are like your unit shipping costs. So it's 10x11, 15x12. So if I just go over here, 10 times x11 plus 15 times x12, and you just keep going like that. And there are 9 terms. So multiply each coefficient here by the variable here. And what happens is that even though this looks like a lot of stuff, there's like 9 terms here. And how many of these will be actually positive if I were to plug in the 3, right? Just 3. Because most of the x's are equal to 0. So if I were to use this example here, 2, 1 is 1, that's over here. And 1, 2 is 1 here, and 3, 3 is 1 here, and all the others are 0, right? All the others are 0, so we just end up going 15 times 1 plus 9 times 1 plus 3 times 1, and of course you're just adding the coefficients. You're going 15 plus 9 plus 3, so you just get 27. Okay. So x just says, okay, use it or not, match or not. We're matching these people or not. Okay. So here were the constraints. Here are the constraints. It says, this says like this kind of thing is going to be the number of projects assigned to person 1. See the go 1 here, 1, 1, 1 here. Okay. So this is the number of projects assigned to person 1. So we have, like the first one is the person number, the leader number. So it's 1, 1, 1, 2, 1, 3. Okay, and then the second values are your project numbers. Okay, so it's just counting the number of projects, number of ones. For the row number for the first person, and it's the same thing: 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3, and then here it says each project must have one assigned project leader. So what this is saying is, so for project is 1, and then you have a person here, 1 or 2 or 3, and so it's 1, 1, and then 2, 1, and 3, 1. So that's the number of people assigned to project 1. So that's just number of people assigned to project 1, and that should be equal to 1. Okay, so here are your constraints, and then here we could see the usual way we model it. Okay, here are your variables, and we know that row totals, if I add up these numbers, should be less than or equal to 1. And here for each column, if I add up the column numbers, should be equal to 1, as it says, here. So here's the row total less than or equal to 1, and these tell us a column total must be equal to 1. Okay, so what we'll do is, well, I don't know if it's okay. We're just okay, go with this. So here what we'll do is we are going to, just for fun, we're going to put ones in the corresponding places of that heuristic answer. Here we got the 1 here, and here we put a 1. Right, so 1, 1, 1, and then if I just leave the others blank, those we interpret as 0. So I don't need to put in zeros. And it's already said, because I already have the sum product function. So sum product of the numbers here, comma, and the variables here, that gives me 27. 27, and here the usual thing, I gotta sum. I gotta sum the 3 cells in the row, and that should be less than or equal to the supply, and I'll put equal to this one here. So that's the equal to this one over here, as if it'll change, but over here. Okay, and then copy this down. Okay, and I did the same thing as before. Column sum must be equal to, and demand was equal to this one here. Okay, then we copy this across. So here are my columns. Here are my my second set of constraints, and in solver it's the same thing. So go with solver, and I guess we're just, as a practice, we'll do it over. So objective is over here, and we want to what? Max or min? Min, right. So we want to minimize changing variable cells are the second table, the x variables here. Then the constraints are, let's say, add constraints. Okay, row totals less than or equal to the supply values. Then we would say add the column totals and equal to the demand values, and then say okay, and let's agree here. Okay, and there's a negative. Okay, let's see. So let's see what will happen. So if I click on solve, and it says okay, and oh look, we saved 1 day. It's 27 before, now it's 26. So so we didn't have to work too hard, right, to save that 1 day. So 26 days, and so we have a slightly different answer from before. So here we have, okay, let's put a different answer. Okay. So we are choosing McClemens for project 1, and Terry still gets project 2, and project 3 is the Carl. So here is the change, the improved assignment. So it's what's this thing, 6? Yeah, so it's 6 plus 15 plus 5. Okay, so that makes sense. That adds to 26 days. Okay, any question at this point? And now, if the if the numbers didn't match up, if you had like more people than you need, or if you had more jobs than you had people, you would do it the same way as transportation problem. So if you had, for instance, okay, so if you had, let's say 3 people, and let's say 5 projects, then you would just need to create the dummy people. Right? So since there are 3 people, so then you would create 2 dummy people. So that is two rows, 2 extra rows, kind of like your unmet demand row. So then you would have here person number dummy 1, dummy 2 for the people and then that would kind of represent the projects that will not be assigned. So the project that gets these dummy people are going to be the ones who don't get anybody assigned. Okay, so projects that are assigned dummy people represent projects that don't get people to work on them. And if So again, if it has to be like one. So if only one project could be assigned to one person. Okay, so I'd like to talk about what you need to do with all this information, what you need to do, and I actually want us to work on a part of the homework here. So, I mean, if you get started here and you kind of figure out what to do, it'll make it easier so if you have questions here, then it's easier. Now you don't have to struggle on your own at home. So I want us to kind of start working on a kind of more challenging problem out of the homework problems. So let's look at the homework.